postulates the Bohr theory. The fact that hydrogen spectrums of Balmer equation was represented successfully, but there were no theoretical proof for it. Therefore, Niels Bohr in year 1914 provided a theory that explained the genesis of its spectrum. The theory provided by Niels Bohr have a new shape of entirely concept of atomic structure. The Bohr model of hydrogen atoms stand on 4 postulates, labeled as Postulate 1, Postulate 2, Postulate 3, Postulate 4. So each of these will be discussed in this video. Postulate 1. Atomic hydrogen made up central nucleus. The nucleus consists of proton with positive charge and electron with negative charge. The electrons are in circular movement, orbiting round with radius around the nucleus. It tells us that atoms is made up of proton, which is positive charge, and then electrons, that is negative charge. It also has a neutron, which is being equalized as a result of equal number of protons and then electrons. Here is a circular part, the radius and the orbit which electrons move around. We can see in this orbit there is a force that keeps the electron moving around the circle. It tends to draw the electron and give the electron the ability to be fixed in a straight inward. Keep on bending the electron inward in a straight inward path. The equation involved in the circular movement could be traced to Coulomb's law. According to the law, force of attraction between electrons and nucleus is F equals to KE. So this is the equations we have seen here. The E will represent the vacuum permittivity. We have Z, which will represent the number of hydrogen atoms. So the above force equalizes a centrifugal force, a force that keeps the electron moving around a circle, mv squared over r, where m stands for mass of the electron and v stands for velocity. Then we have mv squared over r equals to k e squared r squared equals to e squared 4 pi r squared. V squared equals to e 4 pi vrm. Based on our discussion so far, it shows that electron is on motion. For an electron to be on motion, there must be a certain form of energy that keeps the electrons moving. The energy that keeps the electron on motion is called kinetic energy. Below is the formulas of kinetic energy. We have kinetic energy, which is K E equals to half of mv squared equals to 1 over 8 of e squared by vr. Now, take note of the following, that ME stands for mass of electron, which is 9.09 times 10 minus 31 kg. IV it will equal to 1.602 exponent 10 minus 15 j. C, speed of light. This is speed. C stands for the speed of light, which is 3.0 exponent 10 meter per second. E, electrical charge. Quantity is 1.602 exponent 10 minus 19c. R, Rabbi constant, is 1.097 x times 10 7 meter per second. Permittivity of the vacuum is 8.854 exponent 10 minus 15 C2n minus 1 minus n minus 2. H, which is a Planck constant, is 6.626 exponent minus 32 joule-second. We'll look at the second postulate. And the first postulate will refer to orbit to be in circular path, and they have electrons, but it should interest you to know that not all circular orbit allowed electrons. So the orbit that allowed electrons are orbit with angular momentums of electrons mvr, and are the same with multiple integral of h all over 2 pi are permitted. The third postulate, as a consequence of restrictions on the angular momentum of an orbit, the energy of an electron in a given orbit is constant as long as the electrons stay in that orbit. It neither absorbs nor radiates energy, hence the orbit is called stationary state. The total energy E of an electron is that sum of its potential energy. You can see the equation there. The negative because the electrical force between the electrons and the nucleus is attractive, and its kinetic energy 1 over 2 mv squared is equal to 1 over e2 of 8 pi permittivity r. Now from postulate 1, we have E to be equal to 1 over 8 e raised by 2 8 pi permittivity r. So the total energy is equal to half the potential's energy. Now substituting the expression for r from the above, we have E to be equal to me4 8e squared rn squared h squared. All of the quantity on the right hand side of these equations are non-constant except for the arbitrary integer n. Hence, the possible energy of the electrons are determined by the value of n. It should be noted that the negative sign in the energy expression means that the larger the value of n, the higher will be the energy of the electron. The fourth postulate, which is the last postulate, in order to modify one orbit to another, electrons must either emit or absorb energy, which we discussed in our previous video, which is proportional to the distance between the two orbits. Introductions of light energy brings about photons with a wavelength given by hv is equal to e2 minus e1, and the corresponding energy substitution will give the following formula: e2 minus e1 equals to hv equals to hc over lambda equals to me4 its permittivity square h square bracket open, you have 1 over n raised to 2, that is minus 1 over n raised to 2. Now 1 over lambda equals to v over c equals to me4 8 permittivity square ch triple will be equals to 1 over n1 raised to 2 minus 1 over n2 raised to 2. Now equation becomes 1 over n 1 raised to 2 minus 1 over n 2 raised to 2. On the above equation, it examines that the last equation is identical to Balmer equation, which have by m, e, c, and h is a numerical value that can be used to evaluate R constant. The evaluation often gives results that accept closely with the determined experimental value of Weber constant. Processing from Bohr theory, inasmuch n1 can have value 1, 2, 3, 4, 5 till infinity, it provides that other line series should live in the hydrogen spectrum along with Balmer series. Suddenly, to the theory, discoveries of other series has taken place in the ultraviolet, infrared, and far infrared regions of the electromagnetic spectrum. All of these series discovered have a line with a wavelength that are given by Balmer equation if the right value of n1 and n2 are used. Every of the lines stands for a difference between two possible atomic states. Each of these states match with electrons in the hydrogen atom in an orbit, which the radius increase with the n quantum number. The smallest value of n allowed is 1. The reason for this is that the electron is as close to the nucleus as possible, so the system has its minimum energy value to be negative. This value of energy is called a ground state and is the most stable state of hydrogen atom. When a hydrogen atom absorbs radiation, that its energy is equal to the difference between that n equals to 1 and some higher value of n, the atom gets excited. The atom is said to be in a excited state. When atom is excited, it is in an unstable state and they decay fast to ground state, but this didn't usually take place in just a step. For example, when the electron is initially promoted to n3 state, the decay can go directly to the ground state, or it will first decay to n2, n equals to 2, and then before it finally decay to n equals to 1, which is the ground state. Just it shows in the line series of hydrogen atom. Since single n equals to 1 goes to 3, excitations may lead to 3 emission line as n equals to 3. Now 1, n equals to 3, 3 goes to 2, and equals to 2, 2 goes to 1. When the required energy is given to the atom to remove the electron completely, we will end up having electron and hydrogen atom. But if the two particles combine with each other, H plus and E plus now goes to give us hydrogen, because the plus and minus electron balances the charges. The electron may find itself in a state that fits to any value of n, lead to the emissions of many lines. Hydrogen spectrum lines are arranged into different series according to the value of n, where the emissions end or where the absorption begins. The first few series are named after the founder, first observed of the series, and the Balmer series, which lie mostly in the visible region of the spectrum. The Lyman lines, which are in ultraviolet. The remaining series lies in the infrared. The line in every of the series cloud with each other as they move along the series limit that fits to ionization of the atom and is viewed from the starting of the continuum. Here we can see how the series is arranged. The P-Font series and the continuum is on the top. Lyman series, Balmer series, Paschen series, bracket series, P-form series, and the bracket is in the top. Bohr theory gives detail of the hydrogen atom in the following way. When hydrogen atoms get excited, the electrons move to orbit with higher energy level. Upon the electron returning to the ground state or more stable state, it emits photons of energy that fit to the difference between the orbit. Returning of the electron to the ground state can take place directly or indirectly, giving photon or several photons. Each of the spectral series fit to transitions between higher orbit and those having a given n value. It is acceptable to refer to the integer n as a quantum number. Bohr theory can be applied with the same success to a hydrogen-like atom, that is, ion made up of only single electrons, like helium, lithium, etc. Equations of the electron energy and the nth orbit of this ion is given, which is E equals to mz raised by 2 e raised by 4, and where z stands for what? Atomic number. So thanks for watching. That's the end of our video. Subscribe to our channel and have much more of it.